So in our previous video, we talked about considering, want to do a quick recap on having linear and non-repeated roots. Okay, linear non-repeated roots. So that we'll be having something like let's say a over x minus 1 plus b over, let's say, 5x plus 2, and then we'll have our answer or the question, maybe 7x squared plus 16 plus 20 divided by x minus 1 into 5x plus 2. Now, I want to quickly chip in something before we move on to the next segment. Okay, so after this, we'll know the usual step. Now we find LCM. Okay, LCM. Then we either compare. Okay, compare coefficients, or we use the cover up method. Okay, so whichever way you master. Okay, whichever method you master, it will be very good to master one, because I personally have mastered the comparing coefficients method. Okay, and it's actually very fun. All right, so quickly before we proceed, I want us to solve something. Okay, assume we are given let's just clarify on something, and I know this would actually help us a lot. We are given a question. It's x over 28 divided by let's say x squared minus 6x plus 8. Now this denominator here is not linear. Okay, is not linear, just like the one we had in our previous video where we had x squared minus 9. Okay, and we splitted this according to the difference of two squares to be x plus 3 and x minus 3, because x squared minus, or let's say a squared minus b squared, is equals to a plus b into a minus b. Okay, so this kind of things come up again. Okay, where we can reduce um non-linear down to linear is just like resolving quadratic equation or cubic equation or quadratic equations into linear equations. So let's see that we have x squared minus 6x plus 8. Now this can be solved linearly. Okay, can be solved linearly, or let's say you're using quadratic equation. Okay, this can be solved using quadratic equation. Now if you solve this using quadratic equation, you would have x. Okay, you would have x minus 2, and we also have x minus 4. Okay, so we can definitely rewrite this question as 8x minus 28 divided by, since x squared minus 6x plus 8 can be written as this. Okay, we can write it as x minus 2 and also x minus 4. Now this can be solved using repeated right, and repeated and sorry, non-repeated linear roots or linear non-repeated roots. Okay, now what if we have something like this? Let's say we were given 2x squared plus 18x plus 31 divided by x squared plus 5x plus 6. Now the first question we ask is, okay, the denominator, is it linear, is it non-linear? Okay, fine, it's non-linear, right? It's non-linear because of the power of 2. Now, can we reduce it, or can we solve it to give us linear equation? If yes, then let's try again. Okay, so we consider x squared plus 5x plus 6. It can be solved. Okay, you will test it using your quadratic equation, whether using calculator or something. Okay, can be solved using quadratic equation, and when we solve it using quadratic equation, we have it to be x plus 2 and x plus 3. Okay, x plus 2 and x plus 3. So in conclusion, we can now have this. Okay, we cannot have this to be solved further as 2x squared plus 18x to be rewritten, sorry, as 2x squared plus 18x of plus 31, everything divided by x plus 2, right, and x plus 3. Now this we are familiar with. Okay, so we can also have another one. Although these are just scenarios that we might just put in mind. Okay, because I don't want the last video to be very long, but eventually it got very long. So let's just have fun. Okay, so let's say we have x squared plus 3x minus 10 divided by x squared minus 3 2x yeah, minus 2x minus 3. Now the first question is the denominator linear or non-linear? Is it repeating or not repeating? Okay, fine, it's linear. So it is non-linear, right? And it's not repeating. Now, can I make it non-linear? So we know that x squared minus 2x minus 3 can be solved using quadratic equation, right? And we will have it to be x plus 1 and x minus 3. Okay, so we can reversibly rewrite this one to be x squared plus 3x minus 10 divided by x plus 1 and x minus 3. Okay, so these are techniques that are very, very vital, okay, when we are solving partial fractions. All right, so now we want to go into the next segment. Okay, next segment of partial fractions, where we will call it non-repeated non-linear equations. Okay, because we know we reduce them to sorry for the break. Let us find the categories. Okay, these were our categories of partial fractions that we had in our first video. We had non-repeated linear factors. We have now we want to go into non-linear non-repeated factors. Okay, non-linear non-repeated factors, and in our next video we'll look at linear repeated factors. So let's do non-linear repeated factors. Okay, non-linear non-repeated. Okay, non-linear non-repeated factors. Now, what if, back here we can solve these equations quadratically? Okay, quadratically, or then we use some cubic equation to solve it. And the question now comes up, like, what if we cannot solve it using quadratic equation? Okay, let's say we have x plus 1. Okay, we cannot reduce, this is a non-linear equation, we cannot reduce to a to two linear factors. Okay, because this will eventually lead to complex numbers. Okay, so which will be a topic for another day, right? Or what will we do when we have x squared plus x minus 1? Okay, these are kind of questions like x squared plus 4 or 2x cubed, or is it 2x squared? Okay, plus 3. Okay, so these are vital questions we are going to consider. Okay, and obviously we in partial fractions we can combine non-linear equations, non-linear factors and linear factors together. Okay, so we will just get there. We'll get there. Okay, we'll take our time to get there, and I believe it's fun. It's really fun. Okay, now let's look at something. Let's consider the following examples. A, 2x plus 3 divided by 2x plus 1, x squared plus x minus 1. All right, we've agreed that the first question we ask is, are these denominators, are the factors at the denominator, are they linear or are they non-linear? Okay, good. We can say that this guy is linear, and we can say that this guy is non-linear. Okay, that's fine. Can this non-linear here, can it be reduced further, reduced to linear factors, right? Can it be reduced to linear factors? If yes, good. If no, yes. But I'm taking my time, and it cannot be further reduced. Okay, and if it's reduced to little, what's it called? To little complex numbers. So as usual, we have two factors, right? Two factors. First one is 2x plus 1, and the next one is x squared. plus x minus 1. Very good. Now, the first one is what we are familiar with, 2x plus 1. And when it is linear, we just write a, right? Like we did before. When it's linear, we write first a. Now, what if it is non-linear? Now, we will see that the denominator was how to put it? Denominator was x, okay? Was x raised to power 1, okay? Just x raised to power 1. And at denominator, something was written as x raised to power 0. Okay. Now let me try to make this make sense. Denominator here was x raised to power 1, and denominator was written as x raised to power 0. Now the numerator here will be what? X raised to power 2. So the denominator will be what? X raised to power 1 and x raised to power 0. Alright. So we are trying to bring a new concept into this. So this here, okay, okay, was linear, and this system here is non-linear. Okay, so what happens when we have x raised to power 1 and x raised to power 0? We have started with a, good. Now we can now start with b, and we can now start with c and c. Okay, so that means we have a x raised to power 0 here is 1, so that's a into 2x plus 1, and plus b, x raised to power 1 is can be written as x, bx plus c into x squared plus x minus 1. All right, so let's take another example so that we will understand better. Okay, so we understand better. So let's see this b. We don't want to complicate things, so let's take it bit by bit. 2x minus 1, we have 2x squared plus 3 and x squared plus 4. Now let's look at the denominator. Okay, the denominator, are they linear, are they non-linear? Oh, looks like we have square on both denominator, right? So definitely they are non-linear, right? So this is non-linear, and this also is non-linear. Okay, so now the next question we ask is, can it be reduced to linear factors without leading to complex number? Can it be reduced to linear factors? Yeah, it can be reduced, but however it will lead to complex number, because when we want to solve x squared plus 4 is equals to 0, right? So we have x squared is equals to minus 4, and this will be x equals to square root of plus or minus minus 4, and this might lead to definitely lead to complex number, so this will be plus or minus 2i. Okay, this we will talk about soon. All right, so what then is the plan? What then is the plan? How do we go about it? So as usual, we have two factors at the denominator. We have 2x squared plus 3 x squared plus 4. Wow. Now let's go back. X squared at the denominator, abi? X squared at the denominator. So obviously at the numerator we will be left with x raised to power 1 and x raised to power 0, and our denominator will be left with x raised to power 1 and x raised to power 0. All right, so all we just have to do is we start with a number, let's say a, okay, b, c, and d. All right, so this will be plus sign, plus sign. So at the end, this one, at the end we have ax, right, plus b, because x raised to power 0 is 1, sorry, divided by 2x squared plus 3 plus cx plus d over x squared plus 4. Now this is very vital, okay, because if we mistake for not ensuring that okay, let's say for instance we have cx plus d, this is the right answer, and we just write cx without the d, the whole answer will get the whole solution will get wrong from the beginning. So okay, so let's look at another example before we go into solving questions. Okay, this one is just to establish understanding. So let's look at x squared plus 3x minus 7, and we have 3x minus 1, say x squared plus 1. Oof. And then we have 2x cubed, amazing, minus x plus 1. How do we go about this? As usual, we ask the questions. How many factors we have? We have 3. Wow, that's interesting. And are they linear or are they non-linear? Oh, I can say the first one is linear because it's just 3x. Okay, the second one is non-linear, is x squared, and the third is non-linear too, right? Because it has x over 3, and I haven't we haven't done anything as x over 3. Oh my god, what is this guy trying to do? Okay, so now we just go and just let's reduce it. Linear, non-linear, and then non-linear. Can this be reduced? You know what? Maybe I don't even have the strength to even check if they are reduced or not. So let's just see what we can do. So we'll just split them. You can choose to reduce them, and I might choose not to even reduce them. So that's how partial factor works. So we just have to find the best way possible to actually proceed. All right, so let's look at this now. 3x minus 1, x squared plus 1, 2x cubed minus x plus 1. Okay, now the first one is linear. It's very easy, right? So that should be just be x, abi? So let me just have this here. At the denominator of this, I have x to the power 1. So here I'll just have x to the power 0. At the denominator, I have x squared here. So I'll have x to the power 1 and plus x to the power 0. At the denominator, I have x to the power 3. Okay, that's the highest power there. And what do you think I will have at the numerator? So it should be x squared plus x to the power 1 plus x to the power 0. And your mind will be, damn, she's crazy. And so we can now go back and then we have x is power 0 is is 1. Okay, so that's just a. And here we'll have bx plus c, and here we'll have dx squared. Okay, remember there is x squared there plus ex, right? And plus f. Wow, wow. So we have 1 2 1 2 3 4 5 6 6 unknowns in this question. So we should be expecting about 6 simultaneous equations. All right, not to share you guys. So yeah, it's actually very easy. So now that we've understood this, now let's go back to what we have here. Now we have something like this. Okay, we have something like this. Now instead of rewriting this to give me this, instead of writing this to give me this, right? I can just go straight forward and say that I'll have straightforward from here and say that it is x squared plus 5x plus 6, right? And obviously I know that at the denominator I have x squared, right? So I should have it x raised to power 1 and what's x raised to power 0, right? So this should give me a, right? And this will obviously give me b. Interesting, right? But then there is something wrong here. Okay, because when we go ahead and move into the last segment, which is improper fractions, we realize that there is need for us to further divide. That's where our polynomial division comes in. So I advise you, if you have not watched any video on polynomials, please go and do that right away. All right, now having understood this, now let's pick 2 questions. Okay, let's pick 2 questions. So now it will be our choice to either compare coefficients or to use cover up. But to be quite honest, when we get into complicated questions like this, the solution might just lead to comparing coefficients. But let's see what we can do. Let's see what we can do. So let's look at example 1 or question 1. We were given a question. Let's see, 3x plus 2 into x plus 1 and x squared plus x plus 2. Interesting. Now, as usual, the first thing we ask is, are the denominators, are they linear or non-linear? Or I say this guy is linear, okay, and I say this guy is non-linear. Okay, now next thing is, can this non-linear be reduced? Okay, if we cannot, then let's try further. If it can't, then we reduce it, and then, but since we want to make a clear example of whether it can be reduced or not, and how about we go ahead and do this? So we have 2x plus 1 and plus x squared plus x plus 2. Now at the denominator here I have it what x raised to power 1. So at the numerator it will be what, x raised to power 0, and x raised to power 0 is 1, right? So it can just be a, like we have established before. Now at the denominator here, x raised to power 2, and at the numerator it will be x raised to power 1 plus something x raised to power 0. So we started with a before, so it will be b, right, and c. Since x raised to power 0 is 1, so I can remove this, and x raised to power 1 can also be written as x raised to power 1. Okay, let me try and explain all that again. Now at the denominator, like I said, we have x, which is power 1, and since at the denominator we have x to the power 1, we will have x to the power 0 at the numerator. Please have x to the power 2 as the highest power at the denominator here. So at the numerator we have x to the power 1 and x to the power 0. Okay, so we'll start with a, we'll start with b, and we'll start with c. Okay, so definitely there will be an additional sign here. Now anything x to the power 0 is 1, so 1a multiplied by 1, okay, will give me a, and a, c multiplied by 1 will give me c. And since this is x raised to power 1, I can rewrite it as just x. Alright, now let's go to the question proper. So I have 3x plus 2 divided by x plus 1. So x squared plus x plus 2 is equal to a into x plus 1 plus bx plus c into x squared plus x plus 2. Now, very fun. Now let's establish this. So as usual, we would find LCM. Okay, let's evaluate the LCM for the right hand side. X plus 1 and x squared plus x plus 2, and in that case, so we'll have a into x squared plus x plus 2 plus bx plus c into x plus 1. Now 3x plus 2, x plus 1 into x squared plus x plus 2. Now we can see that the denominator of both sides are equal, right? So in that case, right, we'll just have to multiply both sides or just cancel the denominator out. Right, so we'll have 3x plus 2 is equals to a into x squared plus x plus 2 plus bx plus c into x plus 1. Question: how do I go about using cover-up method here? Alright, so if cover-up method is not visible, is not feasible, so fine, let me just go ahead and just do my my equating coefficient. Okay, so let me just open the bracket, right? That's what I was saying. It's very hard to find when we go higher, like in this partial fraction. So actually use cover-up method alone. It's very difficult. We have to combine cover-up method with equating coefficient. Like now we can actually combine cover-up method. Okay, but let's see how we can go about it. So if we combine cover-up method first, okay, I'm still going to use equating coefficients proper. So we just have to put our x to be equals to what? Minus 1. So if x is equals to minus 1 here, everything here will be equal to 0. Okay, everything here will be equal to 0. So with that I can find my a, right, like we did before. But how will I now find my B and C. Question. How will I find my B and C? If I want to find my B and C, I will still have to open the brackets, right? So that I can compare my coefficients. But to make work very easier, okay, I can still find my A first. I can still find my A first. I'm so sorry. Let me find my A first. So let's use cover up method first so that we'll reduce our problems. Right? Yes, that will work well. But we'll still need our A. But as the case may be, let's still combine the method. So let's use cover up method first. So we put x to be equals to -1. So if I put x is equals to -1, so I have 3 into -1 plus 2 is equals to a into -1 squared plus -1 plus 2 plus b into -1 plus c into -1 plus 1. Oh, nice. Everything here is 0. So that means the whole here is down to 0. So all I have to do is just evaluate my a. So I have -3 plus 2 is equals to a. -1 squared is 1 plus times minus. Okay, we give me -1 plus 2. Okay, so I have -1 is equals to a into 2. -1 is equals to 2a, right? So my a will be equals to what? -1/2. Good, that's been established. A is -1/2. Now I come back here now and do my proper comparing coefficients. 3x plus 2 is equals to a into x squared plus x plus 2 plus bx plus c, sorry, into x plus 1. Now let's open the bracket. So this will give me ax squared plus ax plus 2a plus let's open the brackets for power bx into x plus 1 plus c into x plus 1. Now this will give me ax squared plus ax plus 2a plus bx squared plus bx plus cx plus c. Okay, now we have 3x plus 2 here and we have 3x plus 2 here. Okay, now the next thing is to bring cover black times together. So I have 3x plus 2 is the rest of the x squared component, component x squared plus bx squared. Okay, let me go ahead to the x components. So I have ax and I have bx and I have cx, and the constant terms I have 2a and I have c. Now let's make it more sensible. Rise, this will give me x squared and this will give me a plus b plus c into x plus 2a plus c. Amazing. Now let me now compare coefficients. So there's no x squared on the left hand side, so I can just write it as 0x squared. Good. So that means this is equivalent to this. This is equivalent to this, and this is equivalent to this. Okay, and that's amazing. Okay, so let's start with the x squared. So I have a plus b to be equals to 0, equation 1. X, I have a plus b plus c to be equals to what? 3, equation 2, since everything here, okay, is the same thing as something here. Okay, and for my constant term, I have that 2a plus c is equal to 2, equation 3. Now this is 3 equations, 3 unknowns. Now we can solve this simultaneously. However, cover up method has already helped us. We have already found the value for a in cover up method. So it will be easy for us to just implement it. Okay, so since a is equals to minus 1 over 2, let me just implement cover up method, substitution. Okay, so from equation 1, let me find my b from equation 1. So I have a plus b is equals to 0, and my a is minus 1 over 2 plus b, which is equals to 0. So all I'm saying is that my b, if my minus 1 over 2 comes to the other side, is plus 1 over 2, and my b will be 1 over 2. Now my b is found. Interesting. Now I want to find my c now. Okay, so now I can either use equation 2 or equation 3. Anyone work well, but at the same time let me use equation 2. Let's follow an order. Let's use equation 2. So from equation 2, I remember my a plus b plus c is equal to 3. Okay, this is equation 1, equation 2, and equation 3. Okay, essential. So from equation 2, a plus b plus c is equals to 3. And my a is minus 1 over 2, my b is 1 over 2, and my c is what I'm looking for. Right? So minus 1 over 2 plus 1 over 2 is 0. Okay, so definitely c is equals to 3. Now I can write a to be what? Minus 1 over 2, b is 1 over 2, and c is 3. Now, having gotten my values, I will now go back to the bin again. Ooh, we go back here. Okay, we go back here. Very important. In the same order we will write. So in that same order we have it to be 3x plus 2 divided by x plus 1, and x squared plus x plus 2 is equals to a into x plus 1 brackets not necessary plus bx plus c into x squared plus x plus 2. Now I just substitute my values, right? So that's minus 1 over 2 divided by x plus 1 plus ba is 1 over 2x plus 3 divided by x squared plus x plus 2. Interesting. So we can leave our answer like this, or we can just have to simplify further. Okay, so we can simplify further, we can leave our answer like this, but it's essential to simplify further. So I can bring this 2 in the denominator downwards, so that will give us minus 1 2 into x plus 1 plus I want to reduce my numerator. Okay, so I can choose to multiply the numerator here. I can choose to multiply everything by 2, and anything I do to the numerator I do to the denominator. So with respect to that, so 2 multiplied by 1 over 2 will give me x, and 2 multiplied by 6 will give me 6 divided by 2 into x squared plus x plus 2. So this will be our answer. Okay, so quickly let's pick another example. Okay, let's pick another example on the partial fractions of non-repeated non-linear factors. So that should be number 2, I believe. So we have 3x squared plus 2x minus 1 is divided by x squared plus 1, and then divided by 2x squared plus 3x plus 1. Now to solve this, definitely we have 2 x squared plus 1 and 2x squared plus 3x plus 1. So like we know before, this one is x squared, so at the beginning we have x to the power 1 and x to the power 0. This one is also x squared, so at the numerator we have x to the power 1 and x to the power 0. So we'll have a, we'll have b, and we'll have c, and we'll have d. with addition sign at the center. So I can rewrite my x raised to power 1 to just be x. I can rewrite my x raised to power 0 as 1, so I can leave it as that. Rewrite my x raised to power 1 as x and remove my x raised to power 0 because anything raised to power 0 is 1. Alright, so with this done, so I just have to look for LCM 2x minus 1, x squared plus 1, and 2x squared plus 3x plus 1 will be equal to x squared plus 1 and 2x squared plus 3x plus 1. Okay, so I have ax plus b into 2x squared plus 3x plus 1 plus cx plus d into x squared plus 1. My denominators are the same, so it can cancel out, right? So I have 3x squared plus 2x minus 1 is equal to ax plus b into 2x squared plus 3x plus 1 plus cx plus d into x squared plus 1. Now I can now open up the brackets, right? So 3x squared plus 2x plus 1 minus 1 is equals to ax, opening bracket to ax, 2x squared plus 3x plus 1 plus b into 2x squared plus 3x plus 1. Now we're opening the bracket because cover up method is not going to work here. Okay, so we have to just compare coefficients straight up. So plus, now we want to open this, okay? That's plus cx into x squared plus 1 plus d into x squared plus 1. Now with this we have let's open this, okay? So we have 2a x raised to power 3, okay, plus 3x multiplied by ax will give us 3a x squared and plus ax plus open the bracket to b, so we have 2b x squared plus 3b x, okay, plus b. Now open the bracket with, so we've done this also, we now want to do this. So open the bracket with cx, we have cx raised to power 3 plus cx. Now let's open the final brackets. That will give us dx squared plus d. Now everything is equivalent to 3x squared plus 2x minus 1. Now let's collect like things. Let's start with x raised to power 3, right? So we have x raised to power 3 1 and the second x raised to power 3 2. So we have 2a x raised to power 3 plus c x raised to power 3. Now let's open with x squared 1, sorry, this is on this sign, x squared x squared x squared, so plus 3a x squared plus 2b x squared plus c plus d x squared. Now let's pick our x variable, x x x, okay, plus ax plus 3bx plus cx. Now finally let's pick our constant variables, okay? So we have our constants here. Let's use very different sign. Let's use our constant variables this is theta to represent the constant, okay, plus b plus d. Now let's put them in brackets for it to be very easy to compare coefficients. So remember, this is 3x squared plus 2x minus 1, 3x squared plus 2x minus 1. So putting them in brackets, we have 2a plus c all into x raised to power 3 plus 3a plus 2b plus d all into x squared and a plus 3b plus c all into x and then plus b plus d as the constant variable. Now we can now compare coefficients, okay? Now let's compare coefficients. Let's use something nice. Now we can see that there is no x raised to power 3. Okay, this is x raised to power 3. So we just have to add plus 0 x raised to power 3. Okay, so 0 x raised to power 3 and This is for the x squared, all equated to 3, and the x variable. Okay, and finally constant minus 1 is equals to this. So let's follow the blue color. So compare coefficients for x raised to power 3. Okay, and compare coefficients for x squared, for x, and further for the constants variable. Okay, for x raised to power 3, we have that it is 2a plus c, we are following the blue, is equals to 0. And for the x squared, we have 3a plus 2b plus d is equals to 3. And for the x, we have that a plus 3b plus c is equals to 2. And this for the purple, so we have b plus d. This is the bracket, not c, plus d plus d. Okay, is equals to minus 1. So we have 4 equations for unknowns: a, 1, 2, equation 3, and equation 4. How do we go about solving these simultaneous equations? Okay, simultaneous equation. So we have 4 equations and 4 unknowns. So I love solving by substitution. Okay, but let's try and solve this. We'll be fast about it. Maybe next 5 minutes or 10 minutes we are done. All right. So solving this. So from equation 1, we can make c subject of formula. Right. Yes. We can make c subject of formula in equation 1. So from equation 1, we know that 2a plus c is equals to 0. So making c subject of formula is c is equal to minus 2a. So this will be our equation 5. And let's look again. We want to try, and the goal is to reduce these 2 equations into 2 unknowns. Maybe we'll just reduce them to a and c, right? Yes, a and b. We reduce equation 2 and 3 in terms of a and b. So we've reduced the terms of equation 1 and equation 4. So we make c subject to formula in equation 1, and we can also make d subject to formula in equation 4. So that means from equation 4, okay, we have that b plus d is equals to minus 1, and definitely my d is equals to what? Minus 1 minus b. Also, we can call this equation 6. Okay, so let's substitute 5, or yes, let's substitute equation 6 into equation. We want to reduce this, so this is the only term. Okay, this is the only term, that is, we want to reduce 2 and 3, equation 2 and 3 into a and b. So we have to change d completely. So we want to substitute 6, okay, equation 6 as d into equation 2. Okay, please don't get lost. Okay, so reducing them, so we can call equation 2 again. Equation 2 is 3a plus 2b plus d. 3a plus 2b plus d is equal to 3. Okay, so wherever I see d, I substitute minus 1 minus b. So that's 3a plus 2b plus minus 1 minus b is equals to 3. So 3a plus 2b minus 1 minus b is equals to 3. So 3a, and then I have 2b minus b. Okay, that will give me b plus b minus 1 is equals to 3. So minus 1 can go to the right hand side. So I have 3a plus b to be 3 plus 1. So I have 3a plus b to be equals to 4. We can call this equation 7. So let's go back to our original equations. So we can see that for equation 3 now, we have just c to be substituted, and after that we can see that we can also substitute c to be equals to minus 2a. Okay, so let's substitute equation 5 into equation 3. Now equation 3 is a plus 3b plus c. A plus 3b plus c is equal, a plus 3b plus c is equals to 2, and my c from equation 5 is minus 2a. Okay, so wherever I see c, I put minus 2a, so a plus 3b plus minus 2a is equals to 2, right? So we'll have a plus 3b minus 2a is equals to 2. So a minus 2a will give me minus a plus 3b is equal to 2. So this will give me equation 8. Now if you look at equation 7 and equation 8, now we have two simultaneous equations, right? So we have two unknowns, a and b, and two equations. So we can solve these. Okay, maybe solve substitution or something. Let's bring them together. 3a plus b is equals to 4, and minus a plus 3b is equal to 2. So let's say this is equation 7 and this is equation 8. So this obviously can be solved easily. I don't know if I should spend time on it. Okay, let's try and spend time on it. So let's use solve by substitution. So from equation 7, okay, let's make b solve the formula is equals to 4. So b is equals to 4 minus 3a, right? So let's call this one equation 9. So let's put 9 into 8 as minus a plus 3b. That's, well, we're writing 8 now, is equals to 2. And let's substitute b. So minus a plus 3 to 4 minus 3a is equal to 2. So now let's open the brackets. So I have minus a plus 12. Okay, 4 times 3 is 12, minus 3 times minus 3 is 9a, which is equals to 2. Okay, so going further, I have minus a minus 9a plus 12 is equals to 2. So I have minus 10a is equals to 2 minus 12. So minus 10a is equals to minus 10. Okay, so now I have that my a is equals to minus 1. Now since we now know that a is equals to minus 1, so we just have to find b first. Okay, so to find b, so I go to equation 9. I go to equation 9 and find my b. My b is 4 minus 3 into minus 1. 4 minus 3a. Try not to skip steps. So 4 minus 3a, and b will be 4 minus 3 into minus 1, which is 4 plus 3. Now this. Okay. So we just take a deep look at them one by one. Sorry, yes, there is an error somewhere. Thank you. I know someone must have sent it. So here is the error. Okay, I have solved it earlier. So I was looking at an error. So here a should be plus 1. Okay, thank you guys. A is plus 1 because divided by minus 10 divided by minus 10 is 1, positive 1. So we have positive 1 here. So we have 4 minus 3. Okay, so my b is equals to 1. So please, no one is above mistake. Let's ensure that we all work carefully. Speed and accuracy is the goal. So we've solved for a and b, and now we want to solve for c and d. So we just go back to our equations 5 and 6. So for equation 5, we have c is equals to minus 2a. So from equation 5, we have c is equals to minus 2a, right? So c is equals to minus 2 into 1. So c is equals to what? Minus 2. So from equation 6, equation 6 is d is equals to minus 1 minus b. D is equals to minus 1 minus b. Okay, so my d is equals to minus 1 and my b is 1. So d is minus 2. Oh, thank you, Jesus. So at the end, we have our four answers. Let's say a is equals to 1, b is equals to 1, c is equals to minus 2, d is equals to minus 2. So with this, we will now go back to the beginning, okay, where we have all this, okay, quite much. So where we have this, okay, where we have this, then we'll substitute our values for a, b, c, and d. All right, without further ado, like people say, so we have our question. I'll be written here, so it should be very easy. So the question is 3x squared plus 2x minus 1 divided by x squared plus 1, 2x squared plus 3x plus 1 is equals to a into x squared ax plus b plus 1 plus cx plus d into 2x squared plus 3x plus 1. Now with this, we can now substitute our values for a, b, c, and d. So my a is 1x, my b is 1 divided by x squared plus 1. My c is minus 2x, and my d is minus 2 divided by 2x squared plus 3x plus 1. So this will give me x plus 1, okay, divided by x squared plus 1 plus minus 2x minus 2 divided by 2x squared plus 3x plus 1. So we can factorize here with minus this whole thing here. We can factorize it minus. So x plus 1 divided by x squared plus 1 plus minus into 2x plus 2 divided by 2x squared plus 3x plus 1. So eventually this minus and this plus can relate to each other. Please note that it will be wrong if this minus and this plus relates together. It is correct here. Okay, it is correct there. So let's take a deep breath. Oof, quite long. So hereafter, when they relate together, okay, so we will have to be minus, right? So we have x plus 1 over x squared plus 1 minus 2x plus 2 over 2x squared plus 3x plus 1. So this writes everything that we have here down here. So we have it to be what? 3x squared plus 2x minus 1 divided by x squared plus 1 divided by 2x squared plus 3x plus 1. So in this case, this is our final answer. finally. So you can see these steps we went through. Okay, so it's getting a bit more complex. So we first splitted the terms to as expected, x squared plus 1 and 2x plus 3x plus 1. Then we added the numerator x plus b, cx plus d, because we are dealing with non-linear factors. So then we took the LCM, we collected like terms, because cover up method could not work. We proceeded to we went on to use comparing coefficients. So with comparing coefficients, we arrived at these four equations. So all we have to do is just solve these four equations simultaneously. So if we solve the four equations simultaneously using substitution method, so here is the whole process. Solving the four equations simultaneously, we arrived at these four answers. That a is equals to 1, b is equals to 1, c is equals to -2, and d is equals to -2. So then all we just have to do again is to substitute the values of a, b, c, and d into what we have generated earlier from the beginning of the question. So with this, we arrive at the answer. So we have been able to touch on non-linear. Sorry, yes, we are able to talk on non-linear and not repeated factors. And the next thing on our agenda, we'll be talking about repeated factors at the numerator. Repeated factors at the numerator. So we look at linear repeated and also we look at non-linear non-repeated. So we have touched two. Okay, we have touched that two sector. We have touched linear non-repeated and we have touched on non-repeated non-linear. All right, so in our next video we'll talk about repeated linear and also repeated non-linear. All right, thank you guys, and I'm sure that extra understanding has been established.